Hello everybody, it's Damon, Crazy Logics 007 on YouTube, Crazy Logics in the forums. We got a Rockford Fosgate Punch 40 DSM here. It's a little rough, you can see where all this is done. Sorry there's a little glare, I'm not sure what happened, why I'm getting so much glare, but hopefully it'll work out once we get the board out. So this is one of the amps I want to use in the old school stereo by Big D Wiz SPL challenge if they get all the stuff done. And so some of the other amps I want have the same problem that this one's going to have, is it does not have a built-in crossover. And so I got this. Whoa, it's upside down. And I got that sent to me by Jason. He basically said, I don't need it, man, and just cover some shipping, and I did. And so now I have a old school acoustic crossover, three-way. The plug's missing out of it, but it's been nice and soldered and shrink wrapped up with a good power wire here and stuff. If I ever find that style plug, I might restore it and you know, clean it all up and touch it up. We will on this, we will do a little short video. And I'll thank him again, and we'll go over some of the stuff on this, and we'll take it apart. We want to do the guts, you know. Everybody wants to see what stuff is, and I'll kind of a little bit talk through what I know. You know, I'm not an expert by any stretch of the imagination, but what I know about electronic crossovers, and kind of show you a little bit, just the basics, so you kind of understand what they're doing, and what some of the features are on this one. Like I said, it's really cool, but I wanted to give him a shout out. Man, the guys in the classic collector car stereo stuff and the Rockford groups and stuff have just been so supportive and helped me out, you know, send me some parts amps, send me stuff like this, and just so we can keep making videos, because they're enjoying seeing some of these, especially on the old school amps like this. Getting fixed, and at least how to troubleshoot them, so you can get an idea of how badly damaged your old amp or your new amp, because I'll do new amps also. I got a big one coming up, really big. I'm gonna have to move my camera way back to fit it on the bench here and stuff. So anyway, everybody, you know, not a whole lot of people do these older amps, and I love these old amps. This is from whenever I was a teenager and couldn't afford them, but you know, loved them anyway. And I installed a bunch of stereo systems for friends that actually could afford some of the stuff, and so I kind of lived vicariously through them. So I've kind of already taken this one apart because I noticed some problems. This amp came out of a pile that I got. I try to find big bulk deals whenever I can, running around and stuff. You know, a whole bunch of dead amps, pay a low price per amp. Doesn't matter how dead or what good or brand it was when I did this deal. So I got a bunch of good brands and a bunch of junk cheap brands. So practice on the cheap stuff, you know, learn on the cheap stuff, and then do these better brands and stuff, but paid such a low price for all of them. So it's not like, you know, a lot of times you see somebody trying to sell a dead one of these and they want some money for it. They're not really that worth it. You can find this smaller ones like this little 40, no end caps and stuff. If it's dead, it's, you know, pretty much worthless. It's the end caps that are worth money, and then if it's working really good, then it has some value. But if it's dead, a lot of times, by the time somebody thinks they should get some money out of it, even though it's dead, and then somebody pays a repair technician to fix it on these little ones, it's really not worth it. They end up with a whole lot of money in these little ones, unless, like I said, it comes with the end caps, and it's definitely not in bad condition like this one. And everything. So when I got this one, I noticed something right off the bat. So I've already taken the clamps off and stuff, but it's missing its remote turn on, and it's missing its light, its LED, to show that it's powered up. So I went ahead and unbolted it because I wanted to do some inspecting of the boards. So another thing you need to be looking for coming up on the channel, I have this 40 DSM, I have a 200 X2, I got a Punch 150 and a Punch 75, and the Punch, they're both HDs. that I'm going to be doing, but they all need restored. And I got another Punch 75, and I'll show the two Punch 75s side by side. They're both HDs, but they have different finishes to their heat sinks, so I want to point that out and all this stuff. But anyway, I'm going to do a video on restoring the finish on these. There's different finishes for different Rockford amps. Some of them are easy to do, some of them not so easy. But I'm going to be refinishing 4 of them for myself, because we're going to get them repaired here and at least make them look good. I don't have end caps for this, but maybe one day I'll run across them. So look for a video on me just doing all the cleanups of these and how to prep and some other stuff. This one's going to need right here the original screw hole is supposed to be a nice little tapped hole, and it's there, and somebody's blown out a hole here to the side of it and everything. So these are cast aluminum, so they're really hard to TIG weld up and everything else to repair. You got to bake the whole thing, get its temperature up, get that TIG weld to go in there kind of nice, and not screw everything up and then grind it all down. But there's a secret way you can fix smaller things like this, which is buying aluminum machine screws. And we'll go in, and that's what I'm going to show on this one. We'll actually go in on this one, we'll run a tap in, we'll run an aluminum machine screw, cut it off, and then file it all down and sand it smooth, and then be able to re-drill and tap this hole and paint it. And when we put that aluminum screw in, we'll Loctite it in permanent. And once it's sanded and smoothed and this thing's repainted, you'll never know that was there. And then the original hole for mounting the end caps will be there. So I'm going to do a whole thing on that. The nice thing about refinishing them is once you set yourself up and you've kind of got it going, if you've got several amps and they all need to be beat up, you can go through and refinish them all together, making sure you're using the same paint every time and stuff, and then they'll all match beautifully, so when you do an old school install, they'll look real good. So we got into this thing and like I said, notice the remote turn on and the power LED is dead. And also right down here, the resistor for the LED is burnt up and dead. I don't know if I can get a really good, do my little trick here. Let's go to this and see, let's see if it'll focus. Yeah, it's kind of focused. Let's go, oh, not that, this one. There we go. So you can see that resistor is all boogered up, and I've already stuck my meter across it, and sure enough, it is bad. Now, if you notice, right here on the side of this connector, looks like it's got melted. Somebody has put some heat in here, and they this does not look like it's been pulled out, tore out, or anything else. It looks like somebody has stole this, so something may be wrong with this amp where it wasn't working, so they thought it was a good parts amp, and so away they went. Or they had this old junker or smaller amp, and they had a bigger amp. Like I said, these smaller amps are not worth as near as much, so maybe they got this one with no end caps and started stealing parts off of it to fix a bigger, nicer one that they did have the end caps, and that would be worth more value and more rare and harder to find. This one's definitely filthy. There's grime all over where the stuff is, so we're gonna have to do some cleaning and stuff. But let's go through and do our troubleshooting. Oh, and of course, a lot of you, if you follow, I've been busy getting ready to do moves and stuff like that. Also kind of got busy with another little project for my boys and for me, just kind of goofing around there. Got to have a little mini bike. Finally got, I had that, I got the frame, and then I went and got the rest of the parts we need. I've had that motor off of an old Montgomery Ward tiller for, I don't know, 20 years now, and been waiting for a go-kart or a mini bike project, and finally got that one. And so there's my goofy butt on it once I finally got it all running, got the brakes working and testing it out. So gotta have a little fun while you're doing other things. So I got other hobbies besides doing this, so sometimes I'll get a little distracted. ADHD squirrel. But let's go ahead and get into this, and I'll probably do a pause on the recording and then do a little more in a little bit. It's my day off, and I'm trying to do a few chores and get a few things done, and you know, just be productive and have fun. So anyway, we get our multimeter out here, and this is the negative and this is the positive. And just like with every other amp, we're going to stick our little resistor here across the negative and positive. And what we're doing is draining, I'm assuming this is the input filter cap, so that we can get a good reading. And so we got positive here and negative here. And we're just going to watch the meter. And it went right up to 1, so it charged that cap. So we don't think there's going to be an issue with the power supply. Nothing gone there. So let's test this FET. We just go across all the legs. Now that little beep, it went away, so that's good. That's just the cap charging, because we probably got the probes backwards to what we did. So those are good. So we need to talk about this a little bit more, because I really want to make a point of it. Here we go. Get my handy dandy spudger that I use as a pointer. So really basic amplifier here. Power in. Power in is going to come in through an input filter. And sorry if there's loud noise. Trash trucks coming by picking up people's trash. Super annoying. We'll let that pass. I really, professional YouTuber would have stopped all that and redone all this and edited it, but I just don't have time this weekend. A little too busy. A couple months from now, I'll try to get a little more professional. Yeah, right. So, let's see, I want to make sure I tell you this all right, so I'm looking at these all here. So CR5, these are the CRs. So you come in here, this is the power in, this is your power transformer. These are going to be the FETs that switch the power, and they're running off of this board, and there's a TL, let me see, right where, hang on, I'm old. I want to make sure I point to the right one for you. Okay, it's down in here. It's this bottom one. This is the TL494 chip, and that's going to switch these FETs on and off to help make AC that goes through here. These are the rectifiers, so they're going to rectify that switched voltage, which is getting stepped up, and then these are the smoothing capacitors for on the rail voltage. These two right here, this is a 79 012, and this is a 78 012. And that's going to be 12 volt plus and minus regulators, and that's going to be for the opt amps, which are down here on this board, and that's for the input filtering. And there's that dang trash truck again. And then these two are the output for one channel, this channel, and these two are the output FETs for this channel. And these are the source resistors. They'll be called emitter resistors if these were transistors, but since these are FETs, these are called source resistors. And these two boards right here are the drivers for the outputs. So this is the board that... All right, so there will be some editing for the trash truck and for the air compressor. So if you see this jump around a little bit, there was editing for a noisy trash truck that made a double pass, and then my air compressor kicked on, so I forgot to turn it off while I was recording. So what I was saying is inputs. This card is the input for the card that processes the input, and it uses the plus and minus. This, in this case, 12 volts. A lot of times it's 15 volts for the opt amps that processes all the input signals to drive these output cards, which drive these out here. This card, like I said, takes the power, switches these FETs through this. They get rectified, filtered again to make the rail voltage to drive the outputs. I notice that there is instead of the surface mount resistor like this here, there is one that's soldered on there. Now, funny enough, it kind of looks factory, and you know, even that, and there is actually a jumper where they can do that. So I don't think that's wrong. From the factory, it looks like this is a modification they made to the production run. So the other thing that we want to look at here, and I'm going to try to do the magic of my little zoomy zoom cam, because I want to cover all these things. When you're working on your own amp the first time, let's see if we can get over here. You know, you got to look for all this stuff. So let's see, bam. So if I can hold this steady, that's where the LED was, and notice there's a little arc looking right there, and then this is where the remote turn on tab goes, and so it's got solder in it still. So either somehow it got so dang hot, which it does not look like it from here, that it fell out. And I don't think that's possible. I think somebody's swiped this and maybe swiped this, but there was definitely an arc. I sure hope they didn't try to do it. You know, they may have discharged something or something like that. But let's go back to the full stream here and look. And so this would have been the area where that was at, right? No, would have been bam right in here. So we can look at that heat sink and see if there was anything else, but it doesn't look like it. So it looks like somehow somebody arced it. Now I can tell you that this, if I look on the top of the board, goes right here, runs along here, and touches these three tabs. Rockford did a cool thing with their Punch 45. I know the HD series. I know a lot of these DSMs and the ones that come a little bit later, and they have this little card edge. They were able to produce these here when they were building them in the States. They were made in the U.S., and they would make a connector that would slide on here and would provide the power and the ground and the remote turn on and test the outputs. And so they could, right there on the thing, it would probably had a little jig. They'd set this down and probably clamp the FETs down to keep them from overheating, plug it in, run the test. And you know how with Rockford you always got a birth sheet, so they'd probably run it before they stuck it in the heat sink right there on the assembly line to make sure that A, it worked, and B, to get your birth sheet readings, and then it would go down and it would get pasted up and get installed in the rest of the heat sink. I'm assuming that's how it worked because they use this card edge. I don't think, well, let's look. Let's just do this. See, that's got a notch in it. If this is correctly installed, yeah, you could. So actually, I'll bet they get installed, and I'll bet that card just slips in right here, allows them to set everything, plug in, do the test while it was in the actual heat sink to get their birth sheet and to make sure everything worked right. So there is enough room, and they've made that notch in the heat sink to be able to account for that connector. And so that's why, you know, that's something that separates this old school type equipment from the newer stuff is that all the old school stuff like Rockford's got tested and got birth sheets included with it. And nowadays, you know, you get one that's a Korean made board or a Chinese or a Brazilian, and most of those don't include birth sheets. So even, you know, though Rockford now produces their stuff over in China, it's their design, but it's done in a manufacturing house, I think, over in China. You know, Rockford's quality control says, sorry, you still got to test every amp and include a birth sheet with it. And so, you know, that makes a difference between mass-produced and a little bit better quality, and that's where you're paying for some of that sometimes. So we know those are okay. We just checked those. I think that's a factory setup. We'll check that. Reading this little bitty, I know I'm ADHD squirrel. I'm a little in today and stuff, but this says it's a 10 ohm resistor, so we can check that. Let's get the meter in here and just give it a checky check. There we go. Oh no, sorry. It says it's a 100 ohm resistor. It's 101. So there's 100 ohms. So let's check this one. I don't know if my bald. Oh, you guys may have got gratuitous bald head in there. and that's 99. So that resistor is correct. They may have had trouble when they were producing these getting that one in the corner with these big terminals, so they may have had to go with that, or it may have been a little bit of a modification or something. Who knows? It does not look like it was a repair. To me, it looks pretty dang factory. So based on this solder joint on this side and it going through the hole and the fact that it's allowed to be there, so they may have just went that route. So now we need to go back to diode check. I know I'm jumping around. I'm trying to cover all the little things I've seen here, and I try to explain as much as I can. Like I said, I'm not expert, but what I do know, I'll try to share. But we need to test the output FETs here. And it should beep on the center. The center back metal tab should be connected to the middle leg, so you can cheat and just stick it on there and do that. So we're not getting, oh, hang on. Okay, that's just charging up the caps. It does not seem that we have anything dead. Intuitively obvious. I notice I have to get my specs out here. I notice a resistor here. Well, I don't want to leave you guys out. I don't have all the fancy zoom stuff like Louis Rossman and those others that do the repairs. See if that's good enough. We'll make it big. So see that resistor? Just by doing a board inspection, that resistor looks fried to me. So we're gonna have to work on some stuff here. So first things first. Oh, and the other thing, you know, I worry about caps like this. In these older ones, they tend to leak. So I'm going to do some inspecting of that, but it does look like it's got some junk on the board, but it does not look like it's from a leaky cap. You know, this resistor here on this side, you know, and that one there does not look good, and those may be the same ones. A lot of times the circuit's exactly reversed to the other. This one's laid out a little different. That's 219. This is 119. So both of those. So something there has went bad. For certain. It's had a little bit of a rough life, and I bet it doesn't play very well. And it may. I'm gonna have to really inspect this. We may have to unsolder this board and inspect it. Make sure. I don't think any caps have leaked because it doesn't look like there's corrosion necessarily, which electrolytes will eat up all kinds of stuff. So I think we're okay on that. We need to add this and get that light in there and fix this diode. Now I'm going to take this diode off. I don't know what it is. I cannot read it. But I will show you. Yeah, it's just trashed. But I will explain how the Rockford does this on this one and the tricky way that we can use, and you guys need to get this if you're going to want to play. Get you a Ohm's law chart. Real simple. If you're wanting to find amps, volts, resistance, or power, and this is the little wheel chart. And I keep one up on the wall. I printed an extra one off here. If you can read that, that's from the Wikipedia actually page. Just a nice little thing. Print you off one of these, stick it up on your wall. I printed an extra one here. I have one on the wall. Just because it's super easy to reference, and then that way I do that, always have my references up so I don't screw up and say, oh yeah, I need to divide resistance by voltage to get current. No, it's voltage by resistance. You know, you can, if you're like me, little ADHD squirrel sometimes, you don't want to screw up simple math. You know, it's easier just to glance up at your little chart. So what we're going to do is we know that diodes, light emitting diodes, like a small amount of current, somewhere between 5 to 20 milliamps. And I know where Rockford gets. If you actually trace this back, this side goes to the ground, and then this other side, if you flip it over, is going to go over here, and it is on the rectified. These are the rectifiers, and the middle leg is the output of both the rectifiers, and that one goes over there, and these are the pads for the two big caps. Well, that means that this little diode turns on if the power supply is working, and the rectifiers make rail voltage. It's measuring across 1/2 of the rail voltage to turn the little light on. And that's how most all Rockfords are. So all you have to do is get the power supply operating, and once the power supply is operating, measure the rail current or voltage. And if you know the rail voltage, you can get resistance by taking the voltage, E, divided by the current that you need, and we said somewhere between 5 to 20 milliamps, depending on how bright you want your little LED to be. And that will tell you the resistance number that you need. And so this one's going to be somewhere probably around 10K, something like that. I stole some parts off of a bigger parts amp, thanks Chaz. And so I've got the correct LED. I've also got the correct turn on piece. Now I have these, and I was having trouble sourcing these, and I've got a couple of these that I think may work on order if they do end up being the correct thing for the long version, whereas I can get the short version real easy. And somebody asks, I can put the part number down in there. And while I was stealing the parts off the board, I went ahead and stole the little resistor that was in that other board, and I looked it up then real close. It was a 20, this one's a 20K, but that other amp that's a parts amp is a much bigger amp, so it's going to have a higher rail voltage. So I'm assuming this one's about half the size of that other amp, so I'm assuming its rail voltage will be maybe roughly half. So that one will be too much, it'll make this too dim, so we'll find the right size. We're not going to worry about that, but we're going to turn on the soldering iron, and we're going to clean up these two places, and we're going to get rid of this. So we're not going to worry about the light coming on, but I need that remote terminal on there, and we can also power it up and look. We could technically clamp something onto one of these pads, but I'd like to go ahead and fix it. What we'll probably do is try to do that, and then very carefully see if this powers up. Nothing shows dead short. We do have some problems, like I said, there. So I got a feeling that maybe it'll power up. But you never know, and it might pop the fuse. It may be so bad. I'm probably going to do a little cleaning off camera because this thing's just nasty. Between segment 1 and 2, and I'm already 27 minutes in on this one. So we get these couple things done here, and we're going to call it episode 1. I'll do a little cleaning off camera. I clean with isopropyl rubbing alcohol, just what I can get from Walmart. But it needs to be 91% or higher, so that there's very little water in it. And that's what I do my rough cleaning with and stuff. If you've blown fets and there's black carbony soot, you know, I'll clean it. Sometimes you have to use a toothbrush, you know, use Q-tips, stuff like that. And then on my final clean, because isopropyl alcohol likes to leave a little white haze and stuff, I use acetone, and I just put my acetone. These came from IKEA, and I got them in a little Christmas gift kind of thing, several of them. I put my water's in here for my sponge, for my soldering station, and then in my purple one, I've got acetone, and that way I get a smaller one. The other thing I like about these is that they have a very positive cap. So if I have this on my workbench, oh, you guys can't see that. If I have this on my workbench and it gets knocked over, it doesn't spill. And so get you a spill proof, because that big container of acetone, not fun to work with. So I get a little one, I fill these up, and then it won't spill. I use this bowl, I squirt a little in here, and then I'll dip my stuff to clean everything up with. So everything on your workbench needs to be spill proof. Like I said, having water, you know, it needs to be spill proof and stuff too. So let's clean this up a little. We're going to add a little solder to that pad area. Same with these. my specs going here. Let's see how far down can I bring this. See if we can get a little bit better. Man, I really, when I get moved, I'm going to build. This is just a little wooden swing arm that I built, and I'm going to try to build something cool or get a better camera that can get zoomed in a little more. So I'm going to add solder to the resistor that goes to the power LED, and I'm just going to go back and forth until it slides off from one side to the other. That's exactly what I did. Off it fell. Now that's cleaned up, we're going to grab the desoldering tool, and we're going to put a little solder on here so we get good heat flow. And see about getting that out of there. Getting those holes opened up. That did much better there. Add a little here. There we go. And then we need to do the same. And all that's falling out, that's sucked up solder falling out. You need to clean all that off when you're all said and done. That's where your toothbrushes or your little paintbrushes, like I just bought dollar store cheapo paintbrush, help knock that stuff off and then clean it off. And every night I sweep up my workbench area to keep lead from getting in the house. Now we need a tiny bit of, there we go, solder braid. And we're going to make this, we're going to clean up these two pads here. Oh, I need to trim my solder braid. So solder braid, very good stuff to have. I like it. Flux too, for help cleaning up stuff so that you can properly resolder new stuff down. Make it all nice and neat. You'll get, as you get better and better at it, and you get a little better tools, you'll get more anal about it. I did. I got where I was like, oh man, I really want this to look good, and then make it super easy to solder up my new stuff. This is where that little bit of damage was. Looks like that's all okay. So I'm going to put a couple drops of the acetone in here. We'll just go with it. And one little go at it. And clean this up. Like I said, I wish I could get in real close somehow better. That's definitely had an arc to it, so something got a little excited on there. And we'll clean this up. And so everything's going to work on, for this part, except we won't have that resistor there. But you can see how nice that made that resistor. Well, I don't think you can. Here we go. I'm going to try to do this best so that everybody can see how this is done. So there we go. Now we'll make it big. So see how nice and smooth all that got, all that solder off that R1 where that resistor is. If I'd stop shaking. There we go. There. And that makes that pad look like brand new, so it's ready to be soldered on again. That's what you kind of want to look for. It's like cleaning up anything you work on and make sure it works good, is ready to get fixed. So this is a used remote turn on, and yes, I will add my handy dandy little piece of plastic before we're all said and done to reinforce it. Except that one's not wanting to go in there all that perfect. I think I need to straighten out the pins a little here. Taking a little bit of abuse. Let's see if that helps. That might be solder right there. Well, that might be where I need to clean that off a little. Yeah, that was a little bit of it. There it is. My solder flux, or my solder debraid. So we can get that hot enough to clean some of that off. Yeah, that's a little better. It's probably going to be hot now. Ooh, it's a little warm. A little warm. Well, I think we'll get her to go down in there. Doobie-doobie-doo. Yes. Now we can twist just a little bit. Put a little bend in them so they stay, and they got it nice and straight. Go ahead and solder that in. So I want to talk about what's going to be in the second video. The second video will be testing a little powering up, and we're going to talk about a unique feature that's in Rockford's that allows the remote turn on. I think I've done it on the other Rockford one, but we'll talk about it. I've done a tiny bit of research on it trying to look back, and it looks like for guaranteed certain the DSMs and above, the remote turn on feeds the 494 chip to where you can test the the drive signal for the power supply FETs, and it may be on the HD line, the old Punch 45 HD, 150 75 and 150 HD. It may be that way too. I just happen to know this is going to be going in the right way. Otherwise, you'd need to know which side is the positive and negative. Ouch, that was hot. And see if we can't get that soldered on there a little. Get the hold in there. Like I said, these are just used parts off of donor board. All right. And anyway, I want to talk about how the Rockford does that. Rockford does that in a special way. Not only do they, everybody goes, oh, well, that's terrible. If you had a bunch of Rockford amps go fire up at once, they could pull heavy load on the remote. And that is kind of true. They don't do it for very long. So if you had a crap ton of Rockford amps, you actually need to install a relay so that when they first fire up, they do not pull too much. But their circuit is designed where the remote power, the 12 volt coming in, powers up the chip to make this gate drive and get this started. Once the it's producing voltage and makes rail voltage, actually normally off of the positive 15, this one's a 12, so this one may not do it, or it may just stabilize it somehow, or it may have some other rectifiers in here to with a Zener diode or something, but normally they Rockford likes to feed then up through back to this chip through a diode 15 volts instead of your 12.5 to 13.8, but a good solid high 15 volts to the power of this chip, and that helps give it a little heavier gate drive, turn this on a little bit faster, or a little bit easier, sorry, not faster, easier, to do the switching on these and stuff. And that includes all the way up to the big Rockford amps as they get bigger and stuff. So it's a nifty little secret to Rockford stuff. However, I have noticed, I've seen damage before to the diode where it became a short there, and so that when you fired up this amp, when you took the remote voltage away, the amp would not shut off, and that means that little diode that's coming from this secondary voltage is not there to help block and drop whenever this shuts down. It ends up feeding back through what this one is. They're two separate paths, a pair of diodes and stuff, and if a certain one gets shorted, it'll continue to run, won't shut off. But we'll go over all that in the second video, and I think I've got an actual, I don't have this board schematic, but I got a little schematic of some of the power supply in another one that just found by Google. You can find all kinds of stuff by Google, but for this amp, No, I think I got it on the forums. Somebody had it posted up on the forums. It's not for this amp, but it's for a DSM amp like this, and we'll go over a couple of those little circuits and stuff because I think some of you guys want to do it. Well, now we got that fixed, The only thing we need is a resistor, and I'm going to show you, like I said, in the next video, we'll measure the rail voltage, which is what half this is connected to, and we'll do the math on what size resistor we need, and maybe we'll stick more than one. I don't know. We'll see after I get some other work done. Maybe we'll stick more than one size. We'll put one size on and then try swapping it so I can show you the difference in brightness of that LED. You know, if you ended up with if you had an amp and your LED is just dull, you can always go back and lower the lower the size of this just a tiny bit to get a little more brightness, if that helps you. So one of the cool fun things about learning about electronics and then electronics repair. So now we look pretty good here. We're getting there. Next step will be maybe to try powering it up very, very carefully. I may run that off my new supply, so I gotta make up some wires and stuff, but I think we may try that. That way we can current limit it, because I have nothing checked shorted, but noticing the damage in these outputs sections makes me a little worried we might pop the fuse. Something may go bad, may pop bad or something like that. So these are the bias pots, and so if we have to, we'll crank them all the way down. They may help keep everything cool and stuff while we're testing and checking for some things. So all right, thanks for watching. See you in the next video. We'll be, like I said, power and troubleshooting more. I think we can get it done in one more video, assuming these are not dead for some reason, and maybe these just got stressed for some reason and I don't find anything else when I get a chance to get my magnifier here off camera and really look stuff over for some leaky caps. Like I said, I just had taken it apart enough and noticed this, but then when we pulled this out, I noticed those resistors. So given a good inspection, I think I need to inspect that and where these other little caps are to make sure we haven't got no other leakage or something like that. So comments, ask questions. I will try to I'm going to try to give a couple days between this video and the next, so that if somebody has a question, maybe I can write it down and we can answer it when I do this one. So this is actually Friday for me, and so I'll try to maybe record this second one Sunday night, and I'll try to get this one up tonight. So comments, like, subscribe, share with your friends, share with your enemies. You know, have your grandma subscribe. She needs to learn how to repair these old school amps, because she needs bass too. Thanks a bunch, and hopefully we get this thing up and running. We can use this in the old school stereo competition in the under 50 watt class. This is the one I want to use for it, since I don't have a Punch 45. And so this is an awesome little amp. We'll give her a try. Thanks, guys, gals, and everybody else in between. Have a good one.